This is Spencer and Jessica, and we're back for the third simulation.
Hey Spencer, so what are we looking at today? It looks like we're back in New York City.
We are in New York City. We have simplified the simulation, so we're just at 5 nodes. All the data is replicated across these 5 nodes in a single facility.
Okay, so if the data is all in New York, can't cities or data centers fail? What happens if New York goes down?
That's a good question. In this case, your service would go down. So ultimately, what a successful startup or a Fortune 500 company that has, a critical mass of consumers or other businesses that have very high SLAs depending on them, you can't at some point sustain any kind of outage to your service, or you have to make that incredibly unlikely. And the way you do that is you have to geo-replicate your data. So let's get started with this simulation. We're going to turn it on, and you can see that there's client traffic here that's happening. We want to make sure that this service is bulletproof even if New York City fails. So what we're going to do is we're going to geo-replicate this data so that instead of having 3 replicas all in New York City, we're going to have 1 replica in New York City, 1 replica in Atlanta, Georgia, and 1 replica in Des Moines, Iowa. So let's do that. So now we've zoomed out and we're looking at the eastern half of the United States. So you can see that there's heavy rebalancing traffic going on from New York City to Atlanta and to Des Moines.
Yeah, I can see that it looks like the first replica is staying in New York, and then Atlanta's getting all of the second replica, and Des Moines getting all the third.
That's correct, and that's just the way that this configuration is set up for the geo-replication. It can be arbitrary. What you're seeing here is the necessary rebalancing such that we can reliably lose any one of these facilities and still have complete fidelity of our data and access to it. So let's zoom up on New York City. What you're going to see here is, wow, we've lost quite a bit of data. It's been rebalanced out of here. It's not lost, it's now just in a different location. But as you look in here, it's all sparse, but these again are kind of like onion paper that if we composite them all together and stack them, you end up with a view that looks exactly like this one, where all of the registration ranges, first replica live in New York, all of the first replicas of the products ranges live in New York, and so forth. Same thing's true in Atlanta. So if you look in here, you'll see the sparsely located, it's always the second replica. So this should start to look quite a bit like a pattern now. Des Moines, quite the same, only it's the third replica. So let's zoom back out.
Cool, so you promised that you might knock out a city. What happens when you knock one out?
Right, so let's make the facility in New York City fail. Maybe it loses power, maybe its DNS is misconfigured. Now New York City is out of commission. So that means that all of the client traffic that was directed to New York City has come to a standstill, and there's no communication between Atlanta and Des Moines. However, as you can see, client traffic is continuing in Des Moines and Atlanta. And in fact, these 2 sites are moving forward. They're at 7.6 gigabytes now, and New York is still stuck at 7.4.
So what happens when New York comes back online?
When it comes back online, now it's green, it will catch up with both new client requests that start coming inbound to New York, as well as any data that was replicated between Des Moines and Atlanta that didn't make it to New York. Either Atlanta or Des Moines will send copies to New York so that it can catch up.
What happens if you were to lose 2 cities?
So you hope that becomes vanishingly unlikely because the data centers in New York and the data center in Atlanta are going to be on what are called non-correlated failure domains, which means they have different power, different networking. Hopefully changes that are made to them at sort of the configuration level, whether it's a high-level DNS change or some sort of DDoS attack, these things aren't going to be coordinated against multiple data centers at once. But if that does happen, in the unlikely event, let's take Atlanta out and New York City out, you'll see that just like when we had only 3 nodes, we would lose forward progress if 2 of those 3 were out. If we lose 2 of our replication sites, we'll also lose forward progress. So you can see that not even Des Moines, which is up, is able to accept client traffic. If any one of these come back, for example, let's restore New York City, so only Atlanta is out, you'll see that client traffic will resume, and the New York and Des Moines will become synced, and Atlanta will fall behind over time. So the genius of a replication scheme that, like the one Cockroach uses, which is called Raft, is that it doesn't matter which order these failures occur, what order the recoveries occur. There will never be any chance of conflicts. There's never going to be any chance of losing data. And this is something that you have to live with if you're using a traditional monolithic database architecture that has some sort of active-active or primary-secondary replication scheme. So that's pretty much what we're going to show in this particular simulation. I hope you'll join us for the next simulation where we take a closer look at the next big capability that Cockroach offers.
What's that?
It's the ability to partition data across the globe.
Cool.